What is a degree of freedom? It's the fundamental engineering concept that defines the dexterity, flexibility, and versatility of any robotic system. The degree of freedom is defined as the number of independent movements a robot can execute. Simply put, it's the number of axes or joints the robot has. Each joint gives the robot a new way to move, and consequently, a new capability to position its working tool, known as the end effector. Any rigid object moving freely in 3D space has a maximum of 6 possible movements, which we call 6 degrees of freedom. These are perfectly divided. We need 3 for position, moving front-back, left-right, and up-down, or XYZ, and 3 for orientation, rotating the tool along 3 different angles. A 6 DOF industrial robot is the gold standard because it has the same movement capability as a human arm. It can reach any point within its workspace and orient its tool at any angle. Think of ABB's IRB arms or Fanuc manipulators. Their 6-axis design allows them to perform complex tasks like welding, painting, and assembly with complete flexibility. However, the number of DOFs is key. Simpler robots with 3 or 4 DOFs are fast and perfect for repetitive tasks, but can't orient their tool flexibly. Conversely, advanced robots, especially collaborative ones, often have 7 or more DOFs. This extra degree of movement is called redundancy, and allows them to do something crucial, perform a task while avoiding obstacles, or moving through more ergonomic paths. ABB Cobots are a great example of 7-axis systems that use this redundancy for safe human-machine interaction. In summary, degrees of freedom aren't just a number. They are the metric that defines the dexterity, versatility, and real value of any robot in the industry.